Hello, everybody, and welcome to Chapter 1, Functions and Exponents. In this chapter, we will be focusing on two different standards. Our first standard is F.IF.7b, which is I can graph and identify key features of absolute value and piecewise functions. And that's actually like the first part of this chapter. Then the second part of this chapter, we're going to get into the n.Rn.1 and 2, which is I can use properties of exponents to simplify and rewrite radical expressions. But for right now, we're going to start with 1.1, which is absolute value functions. So we're going to focus on graphing the absolute value functions, identifying their key features, etc., just like we did with our quadratic functions. So 1.1 is absolute value functions. Starting out, an absolute value function is a function that contains an absolute value expression. So just very basically, on your next page, if you forgot what that is, take a look at your parent function up here, which we have the function f of x equals the absolute value of x. If you forgot absolute value, it's got those two vertical straight bars. And keep in mind that absolute value means distance from 0. I know a lot of times when we're thinking absolute value, a lot of times we just go, oh, whatever it is, just make it positive. But really what you're talking about here is you're talking how far is something from 0 in the sake of distance, and therefore we consider distance a positive number. So if we're going to graph this function, we're going to start with a table of values. We have our -2, and in order to figure out the value of the function at -2, we're going to substitute it in. So we're going to have the absolute value of -2. Now again, that means the distance. How far is -2 from 0? Well, it's 2 units away, so +2. Then we're going to do the same thing, absolute value of -1. Well, the distance that -1 is from 0 is 1. Absolute value of 0 is 0. 0 doesn't have a distance from 0, it's right there. Absolute value of 1 is still 1. Absolute value of 2 is still 2. So our first point up here, we have -2, 2. So -2, 2. -1, 1. 0, 0. 1, 1. 2, 2. If you take a look at what's going on here, we've already graphed quadratic functions, and quadratic functions made a U. This is an absolute value function. This makes a V. So when you're graphing absolute value functions, they do have essentially a constant rate of change on the left and then a constant rate of change on the right. So it does make that very sharp V with the vertex at the bottom or the vertex on the top if it's flipped around. Unlike the quadratic function, which makes a nice U. Okay, so make sure you differentiate between which one you're graphing. Now, the domain, just like if I were to get my highlighter out here, your domain is all of your x values from left to right. So just like before, I'm highlighting, I'm highlighting, I'm highlighting, I'm highlighting, and this has an arrow. So even as we highlight out this direction, that's -infinity, it goes forever. Highlighting, 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 I'm hitting my domain the whole way, and again, there's an arrow. So your domain on this guy is just like your quadratic function, -infinity to infinity, and I'm going to record that as all real numbers. Your range, again, I'm going to grab my highlighter, is all of your y values, so from low to high. We've kind of got him here. We're highlighting, 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 but he doesn't come down here. So his range, the lowest that the parent function goes, we're going to start at 0, and then highlighting, 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 highlighting the whole way up because it has an arrow. So we could either say from 0 with a bracket to infinity. Or if we wanted to use inequality notation, y is greater than or equal to 0. Whichever notation you want to use, just make sure you either have your bracket on your 0 and or you're using your equal to sign.